In this video, I'm going to show you how we could use Boxplots to identify the outliers in the data. I'm going to use Seaborn and Matplotlib libraries for plotting the data. First, we import the libraries and then read the CSV data. These are all the columns in the data. Now I want to find the outliers in the SAT verbal data. To get the statistical information of SAT verbal data, I use .describe method. I got the count, mean, standard deviation, minimum 25% quartile, 50 quartile, 75% quartile, and so on. Now I'm using matplotlib to plot this data. plt.boxplot, I'm giving the column name, drop all the null values, and I want to label the data as SAT verbal. And I have a bunch of annotations on the plot just to show you what each point or each line means. And I'm finally showing or displaying the plot. So this is the plot. Now this data is represented in this box plot. Talk about the box represents the interquartile range, which is from Q1 to Q3 or first quartile to third quartile. The first quartile or 25th percentile says that 25% of data lies below this value. Median says that 50% of the data lies below this value, which is 500. And third quartile or 75th percentile says that 75% of the data lies within this value, which is, I think, 570. So outlier threshold is based on the thumb rule we have given, which is 1.5 times below the first quartile and 1.5 times above the third quartile. These are the minimum and maximum thresholds I've kept to identify the outlier data. Any data which is beyond the whiskers are called outliers for my data. So we could see these round circles which are above and below this outer threshold. These are the outliers in the data. Next, I'm looking at the weeks worked column. Interested in weeks worked 16 and 17, which is 2016 and 2017 data. So I'm selecting the data or subsetting the data using df.lock. Highest degree weeks worked in 2016 and 2017. Now to get the statistical information of this data, I'm using describe. Only the data of weeks worked 16 and 17 because only these two are numerical data and statistical information is available only for numerical data. Highest degree is a categorical data. That's why we don't have the statistical information for highest degree. Now let's plot the box plot for weeks worked in 2016 and 17 to identify the outliers. I'm again using matplotlib, plt.boxplot, 2016 data, 2017 data, and I'm labeling both the datas. I'm giving a title to the plot and I'm displaying the plot. So this is the box plot for 2016 and 2017. Now we could see the red line here is different at different points. Here the red line is close to 52. That means the median is 52. That means 50% of the people in 2016 worked close to 52 weeks, and in 2017 50% of the people worked close to 50 weeks. The interquartile range is ranging from around 20 to 52. That means there is a lot of variation here compared to 2017. That means many people are working less number of weeks in 2016. Now the whiskers or the outlier threshold minimum value is close to 0 weeks. That means a few people are working very little. Here the whisker is around 15 weeks, the lower bound, and there are many people who are beyond this point. That means there are many outliers in the data. When we compare the weeks worked in 2016 and 2017, We could see 2016 has a wide spread of data compared to 2017, but 2017 has many outliers. That means now let's look at a grouped box plot. Now grouped box plots are used to check the distribution of variables for different categories in the group. For example, we have seen weeks work data here, but when we combine that with, let's say, the highest degree data, in highest degree there are different unique points. For example, high school people, bachelor's people, associates, and so on. So we could plot a box plot for each category of weeks work. For example, high school people, if we want this kind of grouping and then plot a box plot, we could also do that. First, I'm defining a function that returns the descriptive data as a series. So get descriptives is the function, x is the input, and it should output these data: minimum, quartile 1, median, quartile 3, maximum, and count. And I'm to return it as a series. Now I'm using group by to map categories and weeks worked. So group by highest degree and weeks worked, and apply this function get descriptives and unstack it. So now we got a table of the highest degree against all the descriptives: minimum, quartile 1, median, quartile 3, maximum, and count. Now based on this data, I could plot a group box plot. For this, I'm using Seaborn, which is also a data visualization library. So remember, we imported Seaborn as SNS. So sns.boxplot, I'm giving x is the highest degree, y is the weeks worked, data is data, and I'm sorting the box plots based on the highest degree. Setting a title for the plot, setting the x label and y labels, x tick labels, and displaying the plot. So this is a box plot of weeks worked by highest degree. We could see variation in people with no degree. The median is lower for none. That means many worked less than 52 weeks. The bachelor's, master's, and PhD and professionals, these people have worked close to 52 weeks, and there is very less variation in the data. But there are some outliers, which means there might be people who are working part-time, or many are unemployed here. That's what. And the variability is also very low for the professional people. But if you look at, so these are the ways in which we could plot the box plots and identify the outliers in the data. That's all for this video. Thank you for watching.